Arden Labs, specializing in high-performance software consulting, training, staffing, and development. Welcome to Module 14, Profiling and Tracing. Let's get started with Lesson 14.1, Profiling Guidelines.
We're finally at a point in the video where we get to focus on profiling, and we're also going to do some tracing. Now, before we get into that, let me just run through some basics of profiling, some things here that are going to be important. I've talked about some of them so far, but I think it's just going to be good to kind of walk through it again. First thing is how this profiler is going to work. So when we're doing these CPU or even heap profiles, the program's going to be interrupted on regular intervals. We have to remember that. So this means that the program will run longer when all this is happening, and that's okay, right? The idea is we're either trying to find the hot path, or we're trying to figure out the number or the amount of allocations that are going on. So that sigprof signal will be connected in. Now, I've told you this already. The machine must be idle. If the machine isn't idle, then you're going to have a real problem trusting the results. But here's the thing. If you're benchmarking on your local machine like I am, this is a desktop machine. It's handling tons of events. I've got other software running in the background. It's really not that idle. And if you're running on a cloud machine, well, they're probably even less idle than this. I mean, because I run bare minimum on here. So you got to watch out for that idle state. Also understand that these CPUs are designed around thermal scaling and power saving. So if you're pushing the your hardware and the machine's not cool enough, fans are starting to go on, the processor is going to try to protect itself. That could affect the results of benchmarks as well. And so from my perspective, what you always want to do is run these benchmarks a few times just to validate that there's some consistency in the results. But if you're looking for historical benchmarks over time, it's really important that you get some dedicated test software, probably run bare metal, and not update that machine at all if you can, just so the results are consistent throughout all of that history and time. Now, we're going to focus on two types of profiling. The CPU and the memory profiling. Go also has some blocking profiling. I've stopped teaching it because it's so complicated to really gain any value out of it, at least for me. So we're not really going to talk about that. We will talk about tracing as well, which will give us insights on how the program is functioning. So when it comes to the CPU, again, every 10 milliseconds, that program is going to stop. We're going to get a record of the stack trace for all the go routines. And then we're gonna be able to look at those hot paths of code. When it comes to memory profiling, now what we're going to do is taking samples of every 1,000 allocations. You can change the sampling rate, but I haven't ever felt a need to have to do that. So that should be good. And we'll be able to track the number of allocations and the amount that's happening at a line of code. All right, we're not going to focus on any blocking. Really just run one profile at a time, and again, try to keep that machine as idle as possible. A couple of hints, things we're going to be looking for. If we see anything around malloc GC, then we know we're dealing with allocations on the heap. If we see things like syscalls and read and write, we know we're doing a lot of, some sort of I/O around syscalls as well. And we're going to be looking at different things there. Now, a couple last things here. Here's some rules for performance. I've said these things throughout the class, but let's just reiterate them one more time. We never ever guess about performance. When you're guessing, you're probably going to be wrong. Got to make sure those measurements are relevant and we validate them, all right? And always really make sure that something does require profiling. I mean, I'm going to show you how to find some low-hanging fruit for some profiling, but just want to make sure we're maximizing our time in the right place. And again, I just cannot stress enough that we make sure that what we're seeing is correct. Now, there's lots of tools you can use to put load on the system. You got Netcat, you got AB. I'm going to be downloading Hey, which is a tool that Yana over at Google wrote, and I just like it, and we're going to be using that. So any tool you want uses the same flag set as AB and Netcat, so they're really interchangeable. There's lots of good information out there that you can read. I've tried to do as much writing myself. A couple of tools that we are going to be using. while we go through profiling. We're going to be using the time command for sure. I love time. Only works on Linux and the Mac, but it will give us some good, like say, wall clock indications of how fast things are running. If you're on Linux, you can run perf. Go has full support for perf now, and it's a really great tool to get deeper into profiling all the way down into the OS and the machine. All right, so with all this in mind here, we're going to start learning how to take a program that we've now written, hopefully correctly, and start profiling and tracing it to see if there's ways we can improve its performance.